I hate lies. Do you hate lies? I've been given the mission to drive back darkness with light, and I'm here to equip you with the knowledge to do the same. Join me in my mission. My mission is to equip you with the wisdom that the enemy cannot stand against. Do you remember solving right triangles in school using squares? But where did those squares originate from? Well, I'm here to teach you where they originated from. They're from the original 3.6-inch circumference circle. Now, those squares from the original circle are linked to any other circle and triangle, because the triangle is portions of the circle, through a reflection number. And this reflection number comes from multiplying the diameter of the circle times the height of the equilateral triangle inside the circle. Because in the 3.6-inch circumference circle, the height of the equilateral triangle mirrors the diameter, and whenever you multiply them together, it equals 1, which is the hypotenuse of the triangle, but at the same time, it's the 60-degree portion of the circle. And a side note, if you take the height of the equilateral triangle and multiply it by 1/3 of your circumference, it will equal the area of your circle. This will be our example problem, but first I want you to notice this is the squares of the 3.6-inch circumference circle, and the diameter squared is 1.3 repeating, which, if you notice in the volume of a circle formula, we always use 4/3. In a right triangle, the hypotenuse is always the diameter of the circle you're in, and the equilateral triangle height is always 75% of this number. And then you're going to multiply those two numbers together, which I have done already, and you'll get 3600 as your reflection number that will link the portions of the circle, which is the triangle, back to the original 3.6-inch circumference circle. And to solve for the 60-degree side inside this triangle, this height right here, we're going to go back to this circle, and the height squared was 1. And 1 times 3600 is 3600. So you'll take the square root of 3600, which is 60, and this will be the height right here. Now for the 30-degree side of the triangle, you'll go to the 30-degree portion of the circle squared, which is 0.3 repeating. Multiply it by 3600, and you'll get 1200. And square root of 1200 will be the length of this triangle side right here. For the 45-degree triangle inside the circle, 0.6 repeating times 3600 will give you 2400, and this side is the square